So Wayne, are you ready?
I am ready.
For the last video of this exam.
I absolutely am so
Alright,
ready.
so we are go in 3, 2, 4.
No, that's not right.
No?
No, that's not quite.
You see, it's a chemistry joke, Wayne, so they're doing 3, 2, 4.
Oh yeah, I got that. Yeah, 3, 2, 1, 3, 2, 4. You forgot the F.
Oh, should we do it again? Or?
No, let's just get on. Let's get on.
Oh, okay. So, is the last video?
It is indeed of this exam. Now, spectroscopy in a few videos has been in the last sort of bunch of videos, and
we keep mentioning that it's sort of we need to do something else with it, otherwise it's not very helpful.
Yeah. And so a typical question you will get in your exam, normally at the end of the paper, is a big bunch of stuff, and you put it all together, your spectroscopy and all your stuff from AS with your relative intensity and your wave number absorptions.
Put it all together and then hopefully it'll be quite useful. So what we're going to do is we're going to look at this and go,
We are given one extra bit of information that isn't on here.
And that's the empirical formula, which is where?
C2H4O.
C2H4O.
That's its empirical, not its molecular.
So that's something to remember, so what you want to do quite early on is find a molecular.
Yeah.
How are we going to do that?
Well, it's given it to us in this order. That was on top, that was underneath, and that was underneath. In your exam, it doesn't matter what order you do it in,
Okay.
but let's just start at the top.
Alright, so at the top we have two obvious downward peaks.
Yep. One of them's quite broad, one of them's narrow. And what you do is just like in AS, there's nothing new here. You just look at the absorptions, and so the suggestive things it would be.
Yeah, and what are these two things?
The broad one is an OH, and the other one is a C to an O.
Double bonded?
Yeah, double bonded.
Okay.
Now, already I've noticed something.
Oh, I think I noticed it as well, Wayne.
Yes.
Ooh.
Yeah, ooh indeed.
There's two O's, but there's only one in our empirical, so it must mean at least double that.
Yeah, so it's at least C4H8O2, if not another multiple.
Yeah, but to check that we can use our math spec.
We can indeed, and because this was done on a whiteboard, it's not accurate. I haven't done the little lines, so I'll just tell you what it actually is. This value here at the end is 88. Its MZ value is 88.
Yeah. So, but the amount of all of this is 44, so that confirms.
It's exactly double. But it's a good sign when you get stuff like this, when it actually fits perfectly, you know you're on the right track.
Yeah. We can then look over here.
Yeah. So this is the spectroscopy we've been doing. These two are both AS. This is the new thing to combine with it.
Yep. So we have two triplets, which means there's a CH2 affecting something and another CH2 affecting something.
Yeah.
So you can assume they're affecting each other.
Now, they're in two separate places, so they're two distinctive CH2s. So we know that much, and so they're being affected by something else. So it'd probably be an oxygen. That's the usual. There'd be some sort of lone pair affecting the differences.
Yeah. Okay. So they're not. It's not symmetrical like just two CH2s.
Yeah, because otherwise they wouldn't show up if they were symmetrical.
Remember, it's non-equivalent carbons that are affected, and we have one of these little broad bumps that we've been seeing before.
Yeah. So it looks like a singlet, but singlets are distinctive tall things, whereas this is just a lump.
Yeah, so that means it could either be an OH or an NH.
Now there's no N in here, so if anything it would be an OH.
So we're going to put that down as a suggestion. We can change this as we sort of think about it. And we have a singlet, which means something is causing something without hydrogens to do something.
Yeah, so there's something with some sort of gap with no hydrogens in a neighbouring thing and something adjacent.
Yeah.
We don't know what that is exactly just yet.
We do not.
And this OH, it might be worth mentioning, I don't know if it would be a marking point, that it would have been nice if they used the deuterium oxide thing, the D2O.
Yeah, then you'll be able to see if it does disappear. If it does disappear, it's definitely OH.
Yeah.
So that'd be really handy, but they haven't done that, that's okay.
Yep.
There's one last thing we can tell from our graphs.
There is.
And that's here, which will show an ion.
Yes, and it's got an MZ value of 43.
Okay, and we knew that this was 44. Anyway, you can get 43 by removing one hydrogen, which is an ion.
So C2H3O plus. That'll probably be a marking point.
Yeah.
It's the same as AS. They like you to look at the end, and there's normally a sort of obvious ion in the middle somewhere.
So that would be part of our displayed formula.
Yeah. So there's a C2H3O now.
I think that's a good place to start.
I think it is.
So if we have two C's next to each other, and say the one on the left has 3 H's, and the one doesn't have any, right of it has no H's at all, that would explain our singlet.
That's the best way to do it. In fact, there is no other way that would completely fill both of these carbon's bonds and satisfy that without it bonding to other things. So we're going to assume this is an end point,
Yeah.
because there's two. The chances that those two are the two that's in the middle is unlikely.
Yeah.
So if this is a H3, as Triv said, this nicely satisfies the information we have.
It does, and if this has not got a hydrogen, it must have an oxygen, and that's confirmed over here. So we will have a double bonded to an O, and there is one there.
I'll put in blue the bits that we've sort of used. So we've used this.
Yeah.
We've used this now.
But then
We've sort of established that that peak would make sense.
Yeah.
There. We've only got 2 carbons left, and
we do. 2 CH2s, and we're assuming they're next to each other.
Yeah, because if we've got this much, they have to be.
Mm-hmm.
So this is a C to H2. Now these are H's. I will put them on actually. And this is a CH2, and this is the final carbon, so it must somehow have a 4th bond.
It will, and we know the only thing we have left now is our OH, which we've covered everything else.
Yep.
So that means the end must be our OH there.
So I'll circle it on here where we definitely had an OH, but we can also circle it on here where we had a hunch that it was probably an OH.
And that's why they haven't given you they haven't done a purple test, because they thought this was enough.
Yeah.
I think I agree with them.
Yep, so that is a structure of what's the empirical formula is that, and that's how you would go about answering those questions.
Yeah, these questions, they look a bit complicated, but if you just break them down, they're actually quite simple and nice marks.
If you get to a point, if you've gone through this one, and this one, and you're still not sure, go back over it, think about what you've got again. And you might find that when you've done this and clarified you've got these, you go back to an earlier one and go, well, actually, yeah, that's there.
Yeah.
So go back again.
As I said before, this is the last video we're doing for this exam, but not necessarily the last one we're doing about this exam. For example, if you have any questions.
If you struggle with a past paper or a question your teacher might have made up for you or something like that, or whatever, you can leave a comment in the comments below.
Or send us a message on Facebook and we'll reply a video to either to you or put it on YouTube so our YouTube community can see it.
Yep. You can also tweet us on Twitter.
Yes, we will tweet you back.
And that's it from us for this exam. It's kind of a good job really, because we've got to get that sport going, tennis.
Oh,
We've got to get that set up before the next exam.
You're right.